you were given this exercise to answer. So you've seen there that this set of vectors will not be linearly independent, or they are linearly dependent, because even if we assume a linear combinations of u, v, and w, you let that to be equal to 0, not all constants in that linear combination, say AU plus VV plus CW equal to 0, if you let this to be equal to that, not all A, B, and C are equal to 0. So they are not equal to 0, or you cannot make A, B, and C equal to 0. So these vectors are not linearly independent. So let's proceed with some more definitions. First, we will have orthonormal basis. So you have a subspace V, and VI are vectors in the subspace V. So the VIs are basis for V if these two conditions are satisfied. They are linearly independent and they span V. Okay. So if in addition, the inner product of each of the VI in itself, so recall that the inner product VI is actually equivalent to VI, or that is V prime B is equal to 1, and the inner product of the VI with respect to other vectors is equal to 0, then the VIs here are an orthonormal basis for V. Not only basis, but it is an orthonormal basis for V. Yes, na klasiko.
Nakapasok naman sa abordo, no?
Oh, mana. Abordo o sinads.
Nakapasok na lang sila, no?
Hindi ko kainomdom. Murag.
Paso na, no?
Ay, murag sila ang mo-graduate. Murag sila ang mo-graduate. Karon.
Sila mo graduate karon?
Murag.
Silang Marikit?
O si Marikit. Si Marikit. Mo-graduate karon. First sem man na.
Si Marikit.
Umana si Abordo o sinad siyata. Si Marikit ra. O si Marikit ra.
Si Marikit ra lagi.
Oh.
Sige.
Waday ka nagpass?
Nagpass si Marikit na sa lista.
Oo, Marikit ra.
Kapag mag-iskilat ng soccer, nasa soccer.
Ay, dili na. Umana man siguro silang Abordo. Kaya kakita naman ko sa ilang picture sa online.
So, Marikit na lang. So, Marikit naman ako. Sige.
Sige, bye. Okay. Let's continue. Sorry for that. Okay. Here, as a concrete example in R3, so this notation, this arrow here is just telling you it is a vector, no? Kung klaro, it is a vector. Transpose means it is a 3x1 vector. So this is a 3x1 vector. So these three vectors here is a natural basis for R3 if U, which is an arbitrary vector A, B, and C in R3, and U is expressed as a linear combination of the vectors in this S, and you set it to be equal to 0, then you can see in this linear equation that A is equal to 0, B is equal to 0, and C is equal to 0, because this component here will take care of A to be equal to 0. This component here will take care of B to be equal to 0. And this component here would take care of C to be equal to 0. So this set of vectors 1, 0, 0, 0, 1, 1, and 0, 0, 1 will be a natural basis. Of course, there are other bases for S, but these are natural basis for S. Okay, definition 1.22. So two vectors which are of dimension n by 1, and these vectors are u and v, are said to be orthogonal if the inner product of u and v is equal to 0. Geometrically, two orthogonal vectors are perpendicular to each other. So when you have vectors that are orthogonal in nature, or if this is vector u, this is v, and it forms a right angle, then these two vectors are orthogonal. Okay, another definition, if the inner product of a vector u is equal to 1, then we say that this vector u is normalized. So you can normalize any vector v by dividing that vector by its length, or the norm of v, or that is the square root of the inner product of v. No? So if you have any other vector and you want to normalize it, just divide it by its length, say w, and this w, when you try to verify its inner product, w prime w, that is equal to 1. So if the inner product of two vectors are 0, then it is orthogonal. The inner product of a vector in itself, no, u prime u is equal to 1, then we say it is a normalized vector. So a set of p by 1 vectors, say w i's from 1 to p, that are normalized, that is, you can verify that the inner product is equal to I for all, for equal to 1 for all I, and this set of vectors are mutually orthogonal. So usually we define orthogonality, we have two different vectors. So when it is normalized with itself, then we call it mutually orthogonal. So if it is mutually orthogonal, that is, you get the inner product of a product of a set of vectors within itself, no? And it is equal to 0, then we say it is orthonormal. So ortho means orthogonal, at the same time normal, it is normalized. So if all of these are satisfied, it is a basis, linearly independent, and it spans V. The inner product with itself is 1, and the inner product with I not equal to J is 0, then the VI's will form an orthonormal basis for V. Another term is the dimension of a vector space V, which we denote by dim-V, or the dimension of V. This will be the number of elements in any basis of V. So the dimension of V is the number of elements of the basis. Now, if you recall, the rank of a matrix is the minimum of linearly independent or rows or linearly independent columns. Now, these are some well-known result in linear algebra. We will not prove it, but you should be familiar with this because in the proofs in the next theorems and lemmas and corollaries, you will usually use these results in linear algebra. So in all of these, you have a subspace V, and V will always have an orthonormal basis for itself. So what is orthonormal basis? First, you have a basis, and then that set of vectors in that basis will be orthonormal, or the inner product with itself is equal to 0 with other vectors, and normal, the inner product with itself is equal to 1. Okay, any two bases for V has the same elements, or it has the same dimension, because if you recall, the dimension of V is the number of elements in any basis. So this number is called the dimension of V. That is the notation. So if V1 to Vp form a basis for V, then every vector can be written exactly one way as a linear combination of the VI. So kung basis siya, any vector na naaana na subspace can only be written in exactly one way as a linear combination of the VIs. So there is uniqueness of how you can write your linear combination. Next, if the dimension of V is P, your vectors in V is from 1 to P, and these are linearly independent, then they form a basis for V. So, if you recall, ang basis na atong definition, duha, dapat linearly independent and they spans V. But if you can see, if you can show that its dimension is equal to P for these vectors in V, and they are linearly independent. So, dili na kinahanglan na mag-span. Basta linearly independent man ang dimension sa V is P for each of these vectors here from 1 to P, then the VI can form a basis for V. So, that will simplify our definition of a basis, or to show whether a set of vectors is a basis for V. In lecture notes 1, or is it 2 na, these two subspace were introduced to you, no? So if we have a matrix X of dimension n by P of rank R, and if you have a subspace wherein it is some vectors n by 1, such that you can write it in this form for some P by 1 vectors A, and if you have some set of vectors V, which is still n by 1, and you can write that vectors if you pre-multiply it by the transpose of X on V, and that is equal to 0. We have shown that these two subspaces here are this V and W here are subspaces, di ba? So any vector that you can write in this form for any matrix X, and any vector that when you pre-multiply it by the transpose of X, and that is equal to 0, then the dimension of this V here in ani na forma ng mga vectors will be R, or it will take the rank of X, and the dimension of W in ani na forma ng mga vectors will have a dimension n minus R. Take note that this is in R to the n. So you take the dimension of R to the n, then minus the dimension of V. So that will be the dimension of the value of this type of vectors. That is, when you pre-multiply it by X transpose, it is equal to 0. And another thing that is very important, if you want to know whether two subspaces are equal, V and W, you have to show this, or you have to have this assumptions to conclude that V is equal to W. First, you have to show that W is a subset of V, and you have to show that the dimension of W is equal to the dimension of V. So if you can show these two assumptions, then you can automatically conclude that V is equal to W. So those are some important results in linear algebra. We will not prove that, but you should be familiar with it. Okay. Next, if you have a square matrix C, okay, and it has an orthonormal columns, so the columns are orthonormal. Again, ortho inner product is equal to 0, normal with other vectors, normal, inner product with itself is equal to 1. Then we call this C as an orthogonal matrix. So orthogonal na siya, but at the same time, ang mga vectors are not normalized. So if let's C be an orthogonal matrix and I be the identity matrix, again, the identity matrix is a matrix where the diagonal matrix are 1 and the off diagonal matrix entries are 0. So if you have an orthogonal matrix, if you get C transpose C, that is equal to I, or CC transpose, that is also equal to I, and C transpose is equal to its inverse. Thus, an orthogonal matrix C has orthonormal rows as well as orthonormal columns. Because of these properties, no? Okay, so let's have an example. This is actually from reference 2. So if we let A be this matrix, this is a 3 by 3 matrix. This entry here will be your A1. This entry here will be your A2. This entry here will be your A3. So A1 actually is, or A transpose is 1, 1, 1. A2 transpose is 1, negative 2, 1. And A3 transpose is 1, 0, negative 1. So we will try to check if this is an orthogonal matrix. Okay, so according to this, the columns are mutually orthogonal. So ibig sabihin, kung kuhaonin mo si A, the inner product of A1, A2, so the inner product of A1, A2, which is equal to 1, 1, 1, and A2 is 1, negative 2, 1. If you try to do a vector multiplication here, that is 1 times 1 plus 1 times negative 2 plus 1 times 1. So this is 1 minus 2 plus 1, and that is equal to 0. You can do that for all I from 1 to 3. So you look at the inner product of A1, A2, A1, A3, and A2, A3, and all of them are equal to 0. So we say that it's orthogonal. but it's not orthonormal because when you get the inner product of A1 on itself, it's not this. This is the length. So if you get the inner product of itself, say A1, which is just equal to 1, 1, 1, and 1, 1, 1, that is not equal to 1, no? Actually, it is equal to 3. So you can do that for all the inner product in itself. And it's not equal to 1. So to normalize it, you get the length of A. So here, which is equal to 3. Inner product man na. So length is square norm. That is equal to square root of 3. This is the norm of A1. A2, similarly, you can get this. So that to be able to get an orthogonal matrix, you divide each vector by its length. So you will have everything here divided by square root of 3, everything here divided by square root of 6, and everything here will be divided by square root of 2. And then if you try to work on C prime C, that will be equal to your identity matrix. So that the columns of C now, as well as its rows, will be orthonormal. So as a remark, multiplication of a vector by an orthogonal matrix has the effect of rotating axis. So the application of orthogonal matrix is something to do with rotating the axis. That is, if a point X is transformed to Z by pre-multiplying it by an orthogonal matrix, then the distance from the origin to Z is the same as the distance to X. Because this is inner product of Z in itself, that is Z prime Z. If you transform X by pre-multiplying it by an orthogonal matrix, then doing that, you will still get the original inner product of X. So it's just rotation of axis. So that's the importance of having an orthogonal matrix. So, as a review, if you have a basis matrix for X, for V, then the columns of X form basis for V. So the N by P matrix X is a basis matrix for V. If the columns of X form basis for V, the matrix X is an orthonormal basis. If the columns of X forms orthonormal basis for V. Then another term which I always emphasize that you should be familiar with is an invertible matrix. First, it is invertible if it is a square matrix. And then if there exists another square matrix B such that when you multiply AB, that is just equal to BA and that is equal to your identity matrix. If there is such a B and it is unique, so dili man gyud unique na pirmi, no? Makakuha man ka na equal to I, but B will not be always be unique. But if this is unique, then it will be called the inverse of A. And it will be denoted by A inverse. No? So that's why you have A inverse, or A inverse A equal to identity matrix. Now, sometimes that matrix B is not unique. So it's not called A inverse. It is only called A inverse with this notation if it is a unique matrix. But you can always find a a matrix B such that when you multiply it by A, it equal to I. So we say that A here is invertible. But if B is unique, then we denote B by A inverse. Okay. Recall, you have the definition of a rank. That is the number of linearly independent columns of A or the number of linearly independent rows of A. And then the maximum possible rank is said to be a matrix of full rank. No? So if the rank of A is P, then A has a maximum possible rank. If P is less than N. So N by P man imong matrix A. When P is less than N and mao na iyang rank, then tawag nato full rank na ang imuhang matrix A. So in general, the maximum possible rank of an N by P matrix is whichever is the minimum between N and P. We have also these terms, non-negative definite matrix and positive definite matrix. So when we write a matrix in this form or a greater than or equal 0, wala namang pasabot na ang x prime x. Basta matrix gani, greater than or equal to 0. We are referring this notation here as non-negative definite matrix. And if it is strictly greater than 0, we refer to that matrix as positive definite matrix. So you have two terms here, positive definite matrix denoted by this symbol. So if you want to label a matrix which is positive definite, you just write A is greater than 0. If you want to label a matrix which is non-negative definite matrix, then you just write A is greater than or equal to 0. So take note of the star because I will call that later in the results. So what is this? A full rank square matrix is said to be non-singular. So kung full rank siya, non-singular siya. Ano sa gani full rank? Unsa gani condition sa full rank? Are you with me?
Yes, ma'am.
What's the condition of a full rank matrix?
If ang rank is equal to either the row or column, ma'am, sa katong mas gamay sa row or column.
So if you have an N by P matrix and then ang iyang rank katong minimum sa P or N, then we say that it is a full rank. Okay? So kung full rank daw siya, non-singular siya. So unsa may pasabot sa non-singular? So this is very important, ha? So to check first that it is non-singular, it should be full rank. And then kung non-singular na siya, naa siya, when you say a matrix is non-singular, it must have a unique inverse. So since it is unique, we denote it by A inverse with the property that if you cross multiply a matrix A by its inverse or pre-multiply a matrix A by its inverse, it is equal to the identity matrix. So full rank implies non-singular matrix. Non-singular matrix implies it has a unique inverse. Okay? And a positive definite matrix is always non-singular. So kung positive definite ang matrix, it is always non-singular. So kung if it is always non-singular, then it has an inverse. And If it has an inverse, it is unsa? If it has an inverse, it is invertible. Okay? Okay, any questions with the terms? So you have many terms to remember. So now let's go to the lemma 2.2 of Arnold. Okay, so this is the assumption. X is a basis matrix for p-dimensional V subset of R. So p-dimensional V na. Subset lang siya sa R, no? Okay, X is an n by p matrix of rank P. So the rank of X is P. Human si V is an element of RP subset of Rn. Okay? P-dimensional man si V. If these assumptions are satisfied, kinsa ang invertible? Ang invertible si X prime X. No, dili si X ha. Ang invertible si X prime X. So unsay pasabot kung invertible? Na siya unique inverse such that X prime X inverse is equal to the identity matrix. Or pwede po post-multiply or pwede po pre-multiply. So si X prime X ang invertible. Dili si X. Okay, pero unsay condition ana, dapat ang rank sa XP uman si V ang subspace kung dapat p-dimensional. Okay? So let us look at the proof. Let X be a basis matrix for V. So by assumption, kay si V element sa RP, then the dimension of V is P. And since X is a basis matrix, then the rank of X is P. So it follows na positive definite si X prime X. And then kung positive definite siya, non-singular. And then kung non-singular by the star, it has a unique inverse. So if it has a unique inverse, then it is invertible. And then we are done with the proof. So in this proof, we use some definitions and results in linear algebra. So this is a very easy lemma, no? Lemma raman siya. Okay? Next. Okay? You have an if and only if statement. So how do you prove if and only if statement? Okay, P if and only if Q usually is proof in this manner. First, you let P or you assume P and then you show Q. You do some arguments from the assumption and then you show Q. If and only if, the other way around, so kini siya ang paingon ana, no? The other way around is we let Q or you assume Q and then you show P. So this is some methods of proof if you are dealing with if and only if statement. So let P this direction, let P, then show Q. In this direction, let Q, and then you show P. So let V be in V. a vector in your subspace V if and only if you can write V of this form, x beta, for some vector V in a p-dimensional, no? For some vector B in Rp. And this B here is unique. Okay. Another, to show uniqueness, you assume two values or two variables, and then say A and B, and you have to show that A is equal to B. That is uniqueness. So this is the second part. To show uniqueness, you assume two vectors, and then you have to show that A is equal to B. So that is a guide of how to prove if and only if statement and uniqueness. Are you still with me?
Yes, ma'am.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Who is absent? Let's see my screen. Where are you? Who is absent? Nara. Shera is here. Dumagin, LJ, Ganob, Esteban, Maaghop, Kali, and Damian. So Cuenca is not around. 1, 2, 3, 4, 5, 6, 7, 8. You are 10. Cuenca is not around and kinsay wala. Kinsay wala. Si ano? Inyola, no? Inyola and Cuenca is not around?
Yes, ma'am.
Okay, so let's prove this. Okay, X is a basis matrix. Suppose you have X of this form. So this is transpose. Unsa ba si X? Sa dimension ni X n by P. So kada isa ani n ni siya ha, ang mga xi. So kung gisuwat na ako na siya x1, x2 to xp, n by p man eh. So sayo prime man. Okay, this is prime. So x1, x2, xp. Pero kini siya n ni siya kabuok. So n11 to x1n, x1n, and so on so forth. And p ni kabuok. Okay? So this is an n by p matrix. Okay. Let V be in V. This is your assumption. And then you can write, since V is a subspace, no? So actually, naani siya, since V is a subspace, mo nang makasulat kag din. Because if it is a subspace, you can write V as a linear combination of some constant A. So here, for some constant A, you can write it as a linear combination, the elements of X. And then if we will let B be the set of constants that you have obtained, kada isa niya is scalar. Pero kung join na sila, it becomes a vector. So this time A will be RP, B is in RP. So that you can write, so here, this now will be an element, so that this one, B, can be written as XB, no? And this is what you want. You can write B as XB, pareha man na, XB. So kung naa kay X na X1, B is A prime. So dapat patindog na ni siya. X1 to XP, and then mao ni imong B, A1 to AP. Unsa ba ang vector B? Vector B is, this is N by, mali ko, N by P. P is P by 1. So dapat N by 1 mo gawas. So bali ni siya. N by 1. N by 1. Okay, so dapat X. Ang X nako is the prime. Okay. Ang X nako is the prime. Kini siya. So XB is equal to X1 to XP. Man ni siya ang prime. And then dapat wala ni. Ana ra siya. And then B here, ako ramang gunang gibutang prime kay pasabot ana i-column nako. Pero dapat ni wala ni siya. It's just this, and then B will be, XB will be the prime. Dapat patindog. So this is correct, the prime. Para kuhaon nimo si i-prime na nimo, maana na siya A1, A2 to AP. So that when you multiply that, and each of these are just scalar, this is equal to AIXI, no? Which is equal to XB. Which is equal to XP. So delete this, and this is okay because that is prime. So CB patindog. Okay. Because I can B here should be A1 to AP. So, para dili ko mag-inana pagkasulat, I rewrite B as A1 AP prime. So actually, kana na siya. So we have shown we show the other way around for some B in X in RP. Then B is a linear combination of the X's in V because of this. Kaya ang iyang itsura, or actually V is the summation of AIXI where your B here is A1 AP prime. Then since V is a subspace, so it is a set of linear combinations, then V must be in V. So this is just using definitions of subspace being a set of linear combinations. Okay, to show uniqueness, again, you assume two values of a p-dimensional vector or p by 1, and such that Okay, tinuod man ni, no? If and only if. Kini. So this is the assumption. If you have a vector, you can write the vector as x beta. So if you have two vectors in RP, you can write V because V is in V. You can write it as in this manner. So this is the same vector but two different B and B null. So we'll start here. We will use the given X basis, the X matrix, which is a basis for V. So what we did here is just we pre-multiply it by X prime, and we will use the information that X prime X is invertible, so that if it is invertible, it has an inverse. So what we do is we pre-multiply by X prime and then pre-multiply again by X prime inverse, so that you will have an identity matrix, because invertible means if we pre-multiply it, that's equal to I. So it means that this term now will be I, and then B will be equal to this. Similarly, if you start with this, you also get a B null which is equal to this. And since they are the same, then your B must be unique. And it is always equal to X prime X inverse X prime Y. Now later, you will see that this X prime X inverse X prime Y is actually an estimate of your beta hat in your linear regression. Or in terms of projection, this is actually the projection of a vector Y into the subspace V in linear algebra. So in this discussion, we will start first with understanding what is projections, and then relate it later in terms of a matrix X, wherein in statistics we use data set layout in X, no? X form, mga explanatory variables. Okay, so examples of subspaces. So the only subspace in dimension 3 is R3. Recall that this has a natural basis, no? The natural basis is given by the set of vectors 1, 0, 0, 0, 1, 0, and 0, 0, 1. And then this was discussed in an example. The subspace in dimension 2 are the planes that are passing through the origin. Planes, murag papel, no? Niagi sa origin. Of dimension 1 is the lines passing through the origin. And the only subspace of dimension 0 is the origin. So usually up to 3 dimensions okay pa pag-analyze, but if you have more than 4, 3 dimensions okay pa, pero when you have 4, murag lisod na siya i-imagine. So what we do with more than 4 dimensions is to project it into, or project it into a spaces such that it will be data reduced into 2-dimensional. So the PCA, or the principal component analysis, usually do that, wherein from excess I from 1 to P dimensional, it will data reduce it into 2-dimensional. So what it does, it is to project it into a new line or a new space. So you will see that later in multi multi-var analysis. Okay, multivariate analysis. More than 4 or more than 4. So ang kaya lang na ma-imagine and graphically is until dimension 3. So next we have what I have told earlier. We will study this through projections. Projections is like having a mirror image of your vector y into a subspace V, and then ang imuhang plane 2-dimensional na lang. So you can analyze the data here in the space, project it into a plane such that it will just be 2-dimensional. Papel na lang man siya. So kung papel siya, 2-dimensional na lang siya. Okay? Projection. So that is the purpose of projection. So before going to the definitions of projections, let's have a review on the orthogonality of vectors. Actually, this is already familiar to you because this is already introduced earlier, but this time we will concentrate on its notation. Okay? So if we have two vectors u and v in Rn, u is orthogonal to b. This is the notation u perp b. No? So this is perp or perpendicular. So u is perpendicular to v if the inner product of u and v is 0. So for example, if this is your vector u and this is your vector v, these are orthogonal because the inner product of u and v is equal to 0. Geometrically, if you want to see this, you have to plot it, say u, v, and then locate these points. So 1, 2, 3. No, this is not uv. You just have 3-dimensional because this is 3-dimensional. So if we xyz, so xyz, so you have 1, 2, 3, and then 1, and then -1 atras. So this is your vector u, and then 1, 1 y, and 4, 3, 4, somewhere here. Then, di lang tayo gapo akong drawing, but we expect that these two are forms a right angle in a 3-dimensional space. So you have to do some rotation of this para makita gini mo kay 3-dimensional man eh. Kini akong gidrawing. Wala man 2-dimensional lang, but this is a 3-dimensional space. But in the space, these two vectors here are orthogonal, or they form a right angle. So the first definition there is orthogonality between two vectors. The next definition is orthogonality between a vector and a space. No? So u is orthogonal to a subspace V, denoted by this, if the inner product of u with V for all V in your subspace V is 0. Okay? So a vector, orthogonality of a vector to a space V. Here, it's orthogonality of two subspaces. So U is orthogonal to V, written in this symbol if for all elements of, or for all vectors in U and for all vectors in V, the inner product is 0 for all pairwise, vectors of U and V. Okay, so that's it. And then we have another definition, the orthogonal complement of V. You still have a V, which is a subspace of Rn. The orthogonal complement of V, which is written by this, V perp is the set of all vectors orthogonal to V. So, tanang, kung naa kay subspace V, tanang set of vectors dinhi na orthogonal sa mga vectors sa V. So, kung kini si V, mo ni si V1, say for example, kini si W1. So, tanang set na naa sa W1 na orthogonal sa tanang mga elements din sa V. Kasi mao ni V2, so mao ni si W2. Tanang vectors na naa diha, the set of all Wi's such that the inner product of V and W is 0 will be included in B perp. No? Tanang set of vectors such that ang inner product ato na set of vectors with V will be orthogonal. So, kana siya, element na siya sa orthogonal complement. Okay. Next, B mod W, written by this symbol. So, you have another subspace of V. W, subspace gyapon siya, pero subset siya sa V. Then B mod W, which is the intersection of V and W perp, is the set of all vectors in V that are orthogonal to W. The set of all vectors na nasa V, W is a subset of V, na siya diha sa V. Katuta ng set dinhi na W na orthogonal sa tanang element sa V. For example, kini, kung naa siya sa W, then naa siya sa V mod W, or naa siya sa V intersection W perp. Okay, so orthogonal complement B perp. B mod W is B intersection W perp. Shortcut is inaani ang notation, murag B divide W. Okay? So as an example, what time is it? Okay, 10 o'clock. So as an example, suppose you have a subspace B, which is this is R1 cross 0. So, kung XY ni siya, tanang elements na X nasa R, tanang Y element sa R2 man, na 0. Unsa ni siya? This is tanang X na R, tanang Y 0. This is just your X-axis. Are you with me?
Yes, ma'am.
Okay?
Yes,
This is
ma'am.
just your X-axis. Okay, so this is all C in R. And then, of course, minus 0. And then 0. Okay? So let's try to two-dimensional, no? So let's try to get the set of all elements or set of all vectors, or this is just a point na perpendicular sa V. So ang inyong expectation ani kaning y-axis, di ba? Ang y-axis na siya, mao na perpendicular. So any ordered pair in R, kuhaon nimo ang inner product of AB and this vector. So inner product is U prime V or V prime U, no? So you have this. So if we multiply this is prime. So ibig sabihin, ana na siya. AB and then C0. So multiply. So you will have AC plus B times 0. So So that's why this is prime. You get the prime of that. So mauni siya ang prime. So you have this AC plus B0 equals to 0 because by definition of perp. Now, C is not 0. So if AC, so after this, that is 0. If AC is 0 and then C is not equal to 0, so it only means that A will be equal to 0, no? Because what is the meaning of an AC equal to 0? Either A is 0 or C is 0. But C is not 0, so A is 0. So what will happen here? This is the set. This is the set wherein A is equal to 0, the set of 0B. So, unsa man ang the set of 0B? That will be the set of 0B is this line. No? It's a line. If you recall, sa dimension 2, line siya passing through the origin. Dito sa example sa taas, di ba? Ingon ko sa for dimension 2, it is a line that passes through the origin. So this is the line or the set of all points which is perpendicular to V. So if this is V, this is B perp. Okay, so that is an example. And higher dimension will be difficult to imagine, no? Basta yun lang siya, so one-dimensional or two-dimensional. Okay, so here we will show that B perp is also a subspace. How do you show subspace, Gane? You have a vector V in V, and then you can write B as a linear combination of some constant, and then sa gani buhaton? You show that this linear combination is also in V, closed under the operation of taking linear combinations. Are you with me? This is W. Okay. Again, you have a vector in V. You define a new vector W, which is a linear combination of the V's here. If you can show that this linear combination is in V, then it is a subspace. Correct? Ay, naningog. Balik ta unsay definition sa linear combination, dili na. Okay, so let's do that. Okay, B perp subspace. So unsa to akong giingon? Naamoy vector sa B perp. So kung kining vector na nasa B perp, kini siya nasa B perp, then it means that for any other vector sa V, say W, kung kuhaonin mo ang inner product, 0 siya. That is by definition of B perp. Correct? V, W. Okay? Now, sa itong para mapakita na to subspace, maghimo mo og linear combination aning mga vectors sa B perp for some constant A. Tawagon na nako og U. Okay, talking in Bisaya, masayo makasabot tanan. Okay, mas masabtan man ni kung akong Bisayaon.
Yes, ma'am.
Tierra and Kali, are you okay?
Okay, ma'am.
Okay lang, ma'am.
Okay. Sige. So again, makuha mo og V na naa sa B perp. By definition, kung naa siya sa B perp, kanang V na nasa B perp ug bisan unsa na vector na nasa B, ang inner product ana 0. This is just by definition of B perp. Orthogonal complement. Now, para papakita og subspace, maghimo mo og vector na linear combination aning mga V dinhi for some constants AI. Gusto nato ipakita na kining U na imong gihimo naapod siya sa B perp. Or equivalently, kung mukuha ka sa inner product sa U ug sa W, asa gani si W? Asa si W?
Sa V.
Nasa V. Gusto nimo mapakita na si U nasa B perp. So kung naani sa V, naani siya sa W, equivalently of showing that U is in B perp, dapat ang inner product sa U ug W 0 for any W in V. Okay? So tanaw nato ron ang inner product sa U ug W. Sa atong pag-define sa U, inani? Correct? No? And then, you have W. Okay. Unsa gani ni na property sa inner product? Na pwede nato isulat ani? Diba naghatag ko property sa inner product? Asa to dapit? Dito ba taas?
Linearity, ma'am.
Okay, linearity. Asa to dapit? Diba gisuat na ko dinhi kini? Na? Pwede, ang inani na forma, pwede isulat inani. Okay? So, applying that, by linearity of inner product, so you can write it in this manner. Okay? And then, pwede nimo ipagawas ang kini, linearity, no? But, for each element, asa gani si V? Si V1. U ni atong gidefine ha. Asa si V? Nasa B perp. Asa si W? Nasa V. So, ibig sabihin, kini na inner product din is just 0. Correct? So, 0 na siya. This is 0, this is 0, multiply by a constant, which is just 0. So, unsa man atong napakita din Si W na sa V. Ang inner product sa U ug W, 0. So, ibig sabihin, asa si U? Naasa B perp. So, dash U is in B perp. So, unsa man atong napakita ani? Nagsugod ka og okay, nagsugod ka og what? Nagsugod ka og V nasa B perp. Nag-define ka og U na linear combination sa V. Manapakita nimo na si U na sa B perp. So, ibig sabihin, close siya under taking linear combinations of your original vectors V. So, V perp is a subspace. Okay? So, the same thing also is done to show that B mode W is a subspace. So, how do you do it, gani? Start with vectors in B mode W. Then, by definition of B mode W, unsa gani ni? V intersection W perp. So, unsa may pasabot? Kung mga excess na sa B mode W, ang excess na sa V, ang excess na apod sa W perp. Correct? N. intersection. Okay? So now you define a new vector y, which is linear combination of the vectors in B mode W for some constant AI. So we want to show that this y is in B mode W. So to show that, let us get a vector z in W. Okay? So si z nasa W, we want to show that y is in asa. Asa si y. Nasa V mode W. Correct? Or si y nasa V and si y nasa W perp. Okay? Sige. So si y kinira man na siya. Z nasa W. Maura gapon linearity. So this is 0. So ibig sabihin aman si y. So ang kini pasabot ani lang kining nakuha ninyo na equal to 0. Ang pasabot pa lang ana kay nagsugod man ka sa Z na sa W. So ang pasabot lang ani is CY na sa W perp. Correct? Maura na ang atong makuha diha. Okay? Pero tungod kay V is a bigger space, no? So, ibig sabihin, naapot diya si W perp, kung specifically, kung ako nang i-intersection, kung asa man gani siya maka-intersection, tinuod ni siya, no? Kay subset naman siya sa imong V. So, clearly, kung ako nang i-intersection sa V, walay problema, no? So, in here, we just see that Y is in W perp. Since the XI is in W perp and the Z is in W, so this inner product here is 0. But this solution is telling us that Y is in W perp. Diha pa si Y. Kini siya na solusyon. Pero clearly, kung ako ng W perp intersect sa V, nagyapon si Y diha. Intersection raman. Correct? Kung na ako'y V, na ako'y W perp, kung ano mong intersection, nagyapon siya sa, or naa siya din no? So nagyapon siya sa W perp. So this holds. Okay? Question? Dapat master ni ninyong master ni ninyong determining a subspace. Remember, linear model says compre. There is compre for linear model. So, dapat master ni ninyo. Okay? Ang sampling, walay compre ang sampling, but linear model says a compre. So, you should be familiar with it. Okay. So, we will start next meeting with the projection of Y and to V. This topic also should be mastered by you and understood clearly. Okay? So, do you have questions? Saka si Inyola o si Cuenca. Na may balita ni Cuenca?